Hi everyone! For today's video, we will be discussing some double angle identities. We will not be deriving them, but we will focus on how we will be able to use them. The double angle identities are as follows. Sine 2 theta is equal to 2 sine theta cosine theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Now we know the Pythagorean identity that sine squared theta plus cosine squared theta is equal to 1. Thus, cosine 2 theta can take on other forms such as 2 cosine squared theta minus 1 or also 1 minus 2 sine squared theta. And lastly, we have tangent 2 theta equals 2 tangent theta all over 1 minus tangent squared theta. Let's try to validate these identities by giving examples. Our identity says that sine 2 theta is equal to 2 sine theta cosine theta. So let's say we have sine of 60 degrees. We already know that the sine of 60 degrees is square root of 3 over 2. The question is, would it be equal to sine 2 times 30 degrees? Let us see. So using the formula, sine of 60 degrees must be equal to 2 times the sine of 30 degrees times the cosine of 30 degrees. Let's substitute the values. So we have 2 times sine of 30, which is equal to 1/2, times the cosine of 30, which is equal to the square root of 3 over 2. Simplifying this, we see that the sine of 60 degrees is indeed equal to 2 sine of 30 times cosine of 30 degrees, which is square root of 3 over 2 equals the square root of 3 over 2. The previous example shows that if we know the sine and cosine values of any angle, we will be able to find the trigonometric function values of its double angle. Let's see how we can do that in this sample problem. Suppose we're going to find sine 2t, cosine 2t, and tangent 2t, and what we only know is that cosine t is 7 over 25. We also know the location of t, which is between 0 and pi over 2. If we look at our unit circle, we know that t is in quadrant 1. That implies that the values of cosine t, sine t, and tangent t are all positive. We need those values because we see that our identities for sine 2 theta, cosine 2 theta, and tangent 2 theta all need cosine theta, sine theta, and tangent theta. Now, from our given, we know that cosine t is equal to 7 over 25. But how do we find sine t and tangent t? First, we know that cosine t is equal to x over r. So if cosine t is equal to 7 over 25, x is equal to 7, and r is equal to 25. Now we need to find sine t, which we may obtain by getting y over r. How do we obtain y when it's not given? Well, we know that x squared plus y squared is equal to r squared. So y is equal to the square root of the quantity 25 squared minus 7 squared, which is 24. You might say we can either have a positive or a negative square root, but take note that we are taking the positive value since we said that our angle t is found on quadrant 1. So now we get sine t is equal to y over r, which is 24 over 25. Now we have our tangent t. So we know that tangent t is equal to sine t over cosine t, or also equal to y over x. So we have 24 over 7. For easier reference, let's write our values for cosine t, sine t, and tangent t in one table. I suggest that you do this too whenever you're solving problems, so you don't get confused. An organized solution also never hurts. So we write cosine t is equal to 7 over 25, sine t is equal to 24 over 25, and tangent t is equal to 24 over 7. Now you're ready to solve for sine 2t. So again, from the identity, sine 2t is equal to 2 times sine t times cosine t. So we just plug in the values. So we get sine 2t is equal to 2 times 24 over 25 times 7 over 25. Simplifying that, we get 336 over 625. Let's also solve for cosine 2t. So we know from the formula that cosine 2t is equal to 2 cosine squared t minus sine squared t. So cosine 2t is equal to this quantity 7 over 25 squared minus 24 over 25 quantity squared. So we get cosine 2t is now equal to negative 527 over 625. Let's also solve for tangent 2t. So we know that tangent 2t is equal to 2 tangent t all over 1 minus tangent squared t. So plugging in the values, we have tangent 2t is equal to 2 times 24 over 7 all over 1 minus the square root of 24 over, or the square of 24 over 7. So we simplify that and we get tangent 2t is equal to 48 over 7 all over 1 minus 576 over 49. Simplifying further, we get tangent 2t is equal to 48 over 7 all over negative 527 over 49. And then we get the reciprocal of that and multiply with the fraction in the numerator. So we get 48 over 7 times 49 over negative 527. We simplify 49 and 7 and we get only 7 in the numerator. So you have 48 times 7 is 336. And of course, we have negative 527 times 1, so we get 336 or negative 336 over 527. So now we have an easier way to find tangent 2t because we know actually that tangent is the ratio of sine to cosine. So tangent 2t is the ratio of sine 2t to cosine 2t. Therefore, it's only equal to 336 over 625 all over negative 527 over 625. So it's an easier way to find tangent 2t without going through squaring and getting the reciprocal and all those. Once you know your sine 2t and cosine 2t, you just take the ratio of them and then you will get tangent 2t. So finally, we simplify that and we get the same answer, negative 336 over 527. Again, for organization, let's write our final answers. So sine 2t is equal to 336 over 625. Cosine 2t is equal to 527 over 625, or negative 527 over 625. And lastly, tangent 2t is equal to negative 336 over 527. So that's how we use our double angle identities. If you're interested in learning how to derive them, you may check out the detailed explanation in our learning guide. That's it for now. See you in the next video lesson.